Friends, in this session we will understand what are algebraic expressions. Our friend Raghu is given a good opportunity by his parents. On planting saplings, Raghu's parents would reward him in the following manner. If he plants up to 3 saplings in a week, they will give him 4 chocolates for each sapling. And if he plants more than 3 saplings, then he will get 2 chocolates for each extra sapling that he plants. Raghu thinks how many chocolates he will get if he plants 2 additional saplings in the first week. Can you answer this question? We know that on planting first 3 saplings, he will get 4 chocolates per sapling. Hence, he will get 12 chocolates for planting 3 saplings. Now he will get 2 chocolates for planting each additional saplings, which means he will get 4 more chocolates for these 2 additional saplings. So Raghu will get a total of 16 chocolates on planting 5 saplings. Similarly, what if Raghu plants 4 additional saplings next week? For the first 3 saplings, he will get 12 chocolates, and for the additional 4 saplings, he will get 2 chocolates per sapling. This way, Raghu will get a total of 20 chocolates. What if Raghu plants 7 extra saplings in the third week? He will get a total of 12 plus 2 times 7, which is equal to 26 chocolates. Now look carefully at these 3 calculations. Do we see any pattern? In each calculation, everything is the same except for 2, 4, 7. These numbers are the number of extra saplings Raghu has planted. Now, if we replace the number of extra saplings with letter X, we will get this. X is the number of additional saplings planted. We know that here X is called a variable. 12 plus 2x is called an expression or an algebraic expression. Expressions are formed by variables and constants. So, we can say that this expression is formed by x multiplied by 2 and the constant is 12. So now, this expression makes it easy to find the number of chocolates that Raghu got. We have to place the number of additional saplings planted by Raghu in place of x. On the basis of the value of the variable x, the value of the expression will change. Let's understand some points about algebraic expressions. Suppose we are given 2 expressions. What do you think? Expression A is greater than B or B is greater than A? The easiest way to find this is to use the number line. Yes, we can represent an expression on the number line. Let's represent the sum of x and 10 on the number line. Let us assume that variable x is positioned here on the number line. Therefore, x plus 10 will be positioned 10 units ahead of x. Let's represent x plus 10 with the letter P. In a similar manner, we can represent x plus 12 on the number line. It will be 12 units ahead of x. Here, the value of x plus 12 is represented by Q. Here we can see very clearly that point Q lies ahead of point P. It means that the sum of x and 12 is greater than the sum of x and 10. This way, we can compare the expressions by representing them on the number line. Today, in this session, we saw what algebraic expressions are. In the next session, we will see some more examples and understand the elements of algebraic expressions. In the last session, we learnt about algebraic expressions. Friends, in this session, we will learn some elements of algebraic expressions. They are terms, factors, coefficients, like and unlike terms. Take a look at the given expression. We can see here that the expression has two parts. Here, 2x is the product of 2 and x, and then 12 is added to it. We saw in our last video that an expression has various parts which are formed separately at first and then they are added to one another. These parts are called terms. So there are two terms, 12 and 2x, in our expression. Now take a look at this expression. Can you tell me how many terms are there in this expression? And what are they? This expression is formed by the combination of four terms. 4x square, xy minus y cube, and 2. We see that the third term is minus y cube and not just y cube. We studied in our last session that it is necessary to include a minus sign in a term. Now, look at this expression. This expression has only one term. This is a product of minus 12 a, b, c. So we can say that minus 12 a, b, c are the factors of this expression. Now let's look at these four factors. The first factor, minus 12, is a number. So we call it a numeric factor. And the remaining three factors, a, b, c, are variables. And we call them algebraic factors. Numeric factor is known by yet another name. Numeric factors are commonly known as coefficient. So, minus 12 is the coefficient of this term. Now that we have understood what are algebraic factors, now let us try to understand the two types of terms, like term and unlike term. Two terms are said to be like terms when their algebraic factors are the same. And when the algebraic factors of the terms are not the same but different, then they are known as unlike terms. Let us understand it with the help of examples. Suppose 7xy and 15xy are two terms. Are they like terms or unlike terms? Remember, in order to know the type of term, we have to see their algebraic factors. In other words, the variables and not the numbers. X and y are the algebraic factors of these two terms. Hence, we can say that they are like terms. But what about these terms? Are they like terms or unlike terms? In both the terms, there are the same variables x and y, but in 3x square y, xxy are the algebraic factors, and in 3xy cube, xyy are the algebraic factors. Hence, these two are unlike terms as they have different algebraic factors. On the basis of the terms present in an expression, we can classify the expressions. Expression which has only one term is called a monomial. Here are some examples of monomials. An expression which has two unlike terms is called binomial. Here are some examples of a binomial. Similarly, the expression with three unlike terms is called a trinomial, etc. In general, an expression in which one or more terms are present and the coefficients of which are non-zero is called polynomial. These are some examples of polynomials. Today, in this session, we have learned about the parts of an algebraic expression. In the next session, we will see some common mistakes related to algebraic expressions. In the last session, we learnt about the elements of algebraic expressions with examples. Friends, in this session, we will take a look at some common mistakes related to this concept. Look at this expression. How many terms are there in this expression? Perhaps you may think that there are two terms here, but this expression has only one term, which is 4x. Here, 4 is multiplied by x. We generally make the mistake on seeing two elements getting multiplied. We think that the expression has two terms. But that's not the case. This expression has only one term. Then what about 4 divided by x? How many terms are there in it? Here, a number is divided by a variable. But still, it will be considered as one single term. When variables or constants are multiplied or divided, then it is considered as one term. Only addition and subtraction separate the terms. Suppose we are given this expression. Can you tell me how many terms this expression has? I can give you options in order to make it easier. Seeing this expression, we might guess that there are 4 terms present in this expression, but this is wrong. Look at the first and the last part of this expression. Both of these terms are like terms because both of them have the same algebraic factors, which are a and b. That is why, by adding both of them, we have to make one term. That is why, in total, this expression has 3 terms. Hence, the correct option is B. Remember, before counting the number of terms, we have to keep in mind that all the terms should be unlike terms. If we have like terms, then we should reduce them to one term either by adding or subtracting before counting the number of terms. In this session, we have seen 2 mistakes related to algebraic expressions.
In our last session, we saw what algebraic expressions are. Friends, in this session, we will learn about addition and subtraction of algebraic expressions. Let's start. Our friend Raj had 5 pencils and 3 books. His father gave him 3 pencils and 2 books as gifts. How many pencils and books does Raj have now? Raj will now have 8 pencils and 5 books. How did we reach this conclusion? We added the pencils gifted by his father to the pencils he already had. Similarly, we added the books gifted by his father to the books he already had. So, we can see that we have added the existing pencils to the new ones and also the existing books to the new books. Now suppose Raj's sister comes and snatches 4 pencils and 2 books from him. Can you tell me how many pencils and books are left with Raj now? Absolutely correct. 4 pencils and 3 books. Adding and subtracting algebraic expressions is also based on a similar logic. Let's check how. In our last session, we understood what like and unlike terms are. Look at these terms. We know that 2 terms are like if their algebraic factors are the same. 2 terms are unlike if their algebraic factors are different. Just like we added pencils to pencils and books to books, Similarly, we can only add two like terms to each other. We never associate pencils with books. In the same way, we cannot add two unlike terms to each other. The same is the case with subtraction. Only like terms can be subtracted from each other. We cannot subtract two unlike terms. Let's see an example to understand this concept better. Look at these expressions. Let's add these two expressions. We get this after opening the brackets. We know that only like terms can be added and subtracted. That is why we group like terms. Now, when we add the pairs of these two like terms, we get the result. We have learned another simple way to add two expressions, which is to place the expressions in vertical order. When we add the expressions in a vertical order, each expression is written in a separate line, in such a way that the like terms are stacked in a column one under the other. And now we will add according to the columns. First, we will add the terms of this column. Since in our second expression there is no term with a factor, there is no term below 6a. So, we will write this 6a this way. This is our last answer, which is exactly like this. In this session, we looked at the concepts behind adding and subtracting algebraic expressions. In the next session, we will understand it better with some examples. In our last session, we saw the concepts of addition and subtraction of algebraic expressions. We also saw, with the help of examples, how we add two algebraic expressions. Friends, in this session, we will see some more examples of addition and subtraction of two algebraic expressions. Look at these two expressions. Now let's subtract the second expression from the first expression. We should always keep in mind that at least the second expression should be written inside the brackets. This is because we have read that when we subtract one or more terms from an expression, the signs of all the terms change. Thus, upon opening the brackets, we get thus positive x becomes negative x and negative 3 becomes positive 3. Now, we group all the like terms. After adding the like terms, we get the final expression as. Now look at this step. We can also write it as. Now if we compare this part with this part, then we can see that the signs of x and negative 3 are inverted. So, we can say that subtracting a term is like adding to its additive inverse. So, subtracting x means adding negative x and subtracting negative 3 means adding positive 3. This leads us to a simpler way of doing the subtraction. We can subtract these two expressions by placing them one below the other. When we do subtraction in this way, every expression is written in a different line in such a way that the like terms are one below the other in the same column. Notice that we have changed the sign of all the terms of the second expression because we just saw that subtracting a term is like adding its inverse. Now look at this example. Let's solve it. Here, we first have to find the sum of these two expressions and then subtract this expression from that sum. So let's add these two expressions. Let's first write the first expression. Now, while writing the expression which is to be added, we should note that we write the like terms one below the other. Thus, we get the sum of the first two expressions. Now, we have to subtract the third expression from this sum. So let's write this expression first. Now, once again, while writing the third term, we should write the like terms one after the other just like this. Now, we will change the sign of all the terms of the second expression. This is the result we get after adding. So in this session, we learn to add and subtract algebraic expressions using examples. In the next session, we will look at some common misconceptions related to addition and subtraction of algebraic expressions. In the previous session, we saw how to add and subtract algebraic expressions. Friends, in this session, we will look at some common misconceptions related to this concept. Look at this question. Can you tell us what is the right option? The correct option here is B. Now, for some of you, the answer may have been either option A or option C. Let's see why. We have read about the commutative property in the previous classes. Always remember that commutative property is true for addition. For example, 2 plus 4 and 4 plus 2 are the same. But subtraction does not show commutative property. For example, 2 minus 4 is similar to negative 2, but 4 minus 2 is similar to positive 2. This means that 2 minus 4 and 4 minus 2 are not the same. Commutative property is not true for subtraction. Let us now use it here in the given question. Our question says that 5x squared plus 3 be subtracted from 3x plus 4. The expression from which the second expression is subtracted will be written first, and then the expression that is to be subtracted will be written. So, our first stage will look like this. After simplifying the expression of option A, we will get this result. After simplifying the expression of option B, we get this result. We can see that the two expressions are different. Then, option C cannot be the right answer. Hence, option B is the correct answer and not option A or option C. Now let us look at the other misconception. Suppose I asked you this question. I give you two options. Which is the correct option? The correct option is B. Let's see why. This is the expression that will be subtracted. So, our first step would look like this. In our last session, we have seen that when opening brackets while subtracting, the signs of all the terms inside the brackets get inverted. Now this is where we make mistakes. When opening the brackets, we replace 4x with negative 4x, but we forget to replace the symbol negative 5. We write negative 5 in the same way, so our second step would look like this. After simplifying in this way, we get this answer. We have to pay attention that the sign of all the terms of the expression that are subtracted will change. So this would be the correct step. After simplifying, we get this result. Thus, option B is correct. In this session, we saw two misconceptions related to subtraction of algebraic expressions. In the next session, we will learn to multiply algebraic expressions.
In previous session, we learned about addition and subtraction of algebraic expressions. Friends, in this session, let's learn multiplication of algebraic expressions. Let us suppose this is a cinema hall. We can see that here the chairs are arranged in rows and columns. Suppose there are a total of n chairs in each row and a total of m chairs in each column. Can you tell me how many chairs are there in the cinema hall? Absolutely right. The total number of chairs will be equal to the product of m and n. The multiplied result of the number of chairs in each row and each column will be equal to the total number of chairs in the cinema hall. Now, when the number of cinema goers started increasing, owner decided to increase the capacity of the cinema hall. He installed extra 4 chairs in each row and 2 extra chairs in each column. So now, the number of chairs in each row becomes n plus 4 and the number of chairs in each column equals to m plus 2. So, can you tell me how many chairs are there in the cinema hall? Absolutely right. It is equal to the product of n plus 4 and m plus 2. In both cases, we multiplied the two algebraic expressions. In the first situation, the expression n and expression m were multiplied. We know that n and m are two monomials. In the second situation, the expression n plus 4 and expression m plus 2 were multiplied. We know that n plus 4 and m plus 2 are two binomials. We have seen that in some circumstances, we may have to multiply algebraic expressions. But how are two expressions multiplied? Come on, let's see. Let us look at the multiplication of two monomials at the beginning. We saw such a multiplication of two monomials in the first situation. Multiplication of n and m is equal to nm. Look at these two monomials. Let's multiply these two monomials. When multiplying such monomials, we multiply the coefficients first and then their algebraic factors. Thus, by multiplying, we get this product. Now look at these two monomials. Come, let's multiply them. Once again, we will multiply the coefficient first and then the algebraic factors, just like this. So the product will be. If we look at these two steps carefully, we see that the powers of variable x are added based on the rules for the addition of powers and exponents. Let us now go one step further and see how a monomial and binomial are multiplied. Let's take a monomial and a binomial and multiply them. We need to revisit the distributive property before we start. The distributive property tells us that the multiplication of a and b plus c is equal to the sum of multiplication of a and b and multiplication of a and c. This property will help us to multiply a monomial and a binomial. Exactly as the distributive property, it will be equal to the sum of multiplication of 2x and 3 and multiplication of 2x and 2y. Now, these are multiplications of both monomial and monomial. We have just seen how two monomials are multiplied. So, our final product will be. Now that we know how to multiply two monomials and a monomial and a binomial, it will be easy to understand the multiplication of a binomial and a trinomial. Suppose we have this binomial and this trinomial. Come, let's multiply them. Now, using the distributive property, we will get. Now, this is a situation of multiplying monomials and polynomials that we just saw. Using the distributive property here and here, we will get. After simplifying in this way, we will get this result. In this session, we looked at multiplication of algebraic expressions. In the next session, we will see some more examples of multiplication of algebraic expressions. In the last session, we saw how two algebraic expressions are multiplied. Friends, in this session, we will see some more examples of multiplication of algebraic expressions. Come on, let's start. Let us suppose we have to multiply these two expressions. It is a matter of multiplication of monomials and binomials. We know that we have to use the distributive property here. So this will be equal to the sum of 3ab multiplied by ab square and 3ab multiplied by a cube d. Now both these terms are multiplications of a monomial and a monomial. Thus, after simplifying, we will get. This is our final answer. When it comes to multiplying algebraic expressions, polynomial and polynomial multiplication is the most interesting. Here's an example. We are multiplying a polynomial with 4 terms and a polynomial with 2 terms. Every term of this expression will be multiplied with this binomial. Let's multiply the first term with that. This would be equal to the multiplication of 2pq and 3q minus 5. Thus, we multiply all terms by binomial. Next, 4q cube multiplied by 3q minus 5. After that, we multiply next p cube and 3q minus 5 and finally 4 and 3q minus 5. Now, we have multiplication of a monomial and a binomial. So, we will solve this by using the distributive property like this. Thus, after multiplying these monomials, we get. Look at these terms. There are no terms here that have the same algebraic factor. So, we do not have any like terms and hence it cannot be simplified further. Let's look at one more question. Simplify this expression and find its value for x equals 2. We can see it as two parts that have been combined to form this expression. So, let's solve them separately and then combine the results of both. Let's think about the first part. We can see that it is a matter of multiplication of binomial and binomial. We have seen how to solve such expressions. Every term of this expression will be multiplied by this binomial. So we get this. Now, we use the distributive property. After multiplying these terms, we will get. We can see that we have two like terms here. So, let's group them together. Now, let's move to the second part. This is a simple case of multiplication of monomials and binomials. We just multiply this x with every term in this binomial. After multiplying these terms, we get. Now that we have the result of these two parts, we just have to add them. Here, 8x and 5x are the like terms. So, add them. Now we just have to place them in decreasing order of their powers, just like this. Wait! Our work is not over yet. Now we have to calculate this expression for x equals 2. For this, we just have to substitute x with 2 in this way. After simplifying this, we get this as our final answer. In this session, we looked at multiplication of algebraic expressions. In the next session, we will look at some of the misconceptions related to this topic. In our last session, we looked at examples of multiplication of algebraic expressions. Friends, in this session, we will look at a simple mistake we make related to the multiplication of algebraic expressions. Come on, let me ask you a question. Let us suppose we have these two monomials and we are asked to multiply them. What is the correct option? The correct option is B. Now many of us would have answered as option A. But this is not the correct answer. Come, let's see why. In the previous session, we learned how to multiply two monomials. When we multiply two monomials, we make a group of coefficients and a group of algebraic factors or variables. So, let's do this. Now, we just need to multiply the coefficients together and multiply the algebraic factors together. We do not make mistakes when multiplying coefficients, but we often make mistakes when multiplying algebraic factors. We can see that x square y is common here. So when multiplying these algebraic factors, we keep x square y as it is and just multiply z. So the result we get is 21x squared yz. But this is a wrong way of multiplying algebraic factors. When multiplying algebraic factors, we should form groups of similar variables with their powers in this way. Now, we will multiply the similar variables with their powers. So, x square multiplied by x square will be x to the power 2 plus 2, which is equal to x to the power 4. This is according to the exponent and power rule that we studied in junior classes. Similarly, y times y will become y squared and z will remain the same. So, this is the correct answer, which is option B. In this session, we made a simple mistake related to the multiplication of algebraic expressions. Raj is working on a problem that involves solving large numbers. He reaches a point where he needs to find the square of 103. But he realizes that multiplying 103 by 103 will take a lot of time. Can you help him solve this problem in a better way? So friends, in order to do this, let us learn about a mathematical concept called identities in this session. Let's first write 103 as the sum of two simple numbers like 100 and 3. That means square of 103 will be equal to the square of 100 plus 3. But why did we split it into 100 and 3? Basically, 100 plus 3 square will be like this. We can see that it is very easy to find the values of 100 square and 3 square. And it is also easy to find the value of this term. Therefore, we will get this as answer. Isn't it easier than multiplying 103 by 103? But wait, you must be wondering, where did this come from? Let's find it out. 100 plus 3 square can also be written as this. Let us now simplify the right-hand side by using the distributive property. This is what we get. Now observe that multiplying 100 by 3 and multiplying 3 by 100 is the same thing. So these two can be combined, which gives us 2 multiplied by 100 multiplied by 3. So this is how we got the previous expression. Now suppose we have replaced 100 with variable a and 3 with variable b on both left and right hand sides. We will get, by using this, now we can find the square of decimal numbers. Let's consider the example 6.2 square. We will divide 6.2 into two simple numbers, 6 and 0.2. Now, in this equation, we take a as 6 and b as 0.2. Then, we will get the value of 6.2 square like this. So, this equation is very useful for us. This means that whenever we have two numbers a and b, then the square of their sum will be equal to the sum of a square 2 times a times b and b square. We will get the expression on the right side when we multiply a plus b by a plus b. We have seen this kind of equations before. Solving this equation gives us only one value of x, which is 2. But we have seen that this equation is true for two different values of a and b. Earlier, we considered a as 100 and b as 3. After that, we considered a as 6 and b as 0.2. Now you can stop here and try to put any other number in the place of a and b. You will see that this equation is true for any values of a and b. This type of equation, which is true for every value of the variable in it, is called an identity. For any value of a and b, the expression on the left side is equal to the expression on the right side. In this session, we have seen what an identity is. We have also seen the proof of this identity. In the next session, we will see some more examples of this identity. Friends, in the previous session we have seen what an identity is. We have seen this identity also. Now in this session, we will see some examples and understand how this identity is applied. Can you find the value of 1015 square? This identity makes it easier to find the solution of large numbers. Our first step will be dividing this large number into the sum of two simple numbers. So 1015 will be written as the sum of 1015. Now let's apply the identity now. We will consider the value of a as 1000 and the value of b as 15. Now, we will apply the identity and expand this. So, a square will become 1000 square. In the same way, 2ab will be written like this and b square will be like this. After simplification, we will get this answer. So, we have seen that by applying this identity, one can easily find the square of any number. Let's move on to the next example. Can you guess the square of this expression? Like in the previous example, this identity will help us in solving this problem too. But what shall we write in the place of A and B? Here we will consider A as 5x and B as 7y. Therefore, the value of 5x plus 7y square will be equal to this. After simplification, we will get this as our final answer. This cannot be simplified further because there are no similar terms. So we have seen that we can also use this identity to find the square of an expression. Let's see one last example. Can you find the value of 3xy plus z square? You are absolutely right. Once again, we'll apply this identity. But what shall we write in the place of A and B? Here we can consider A as 3xy and B as z. So in the right-hand side, we will get 3xy square plus 2 multiplied by 3xy multiplied by z plus z square. After simplification, we will get 9x square y square plus 6xy plus z square. So friends, in this session, we have seen how this identity is applied. In the next session, we will see some common mistakes which occur while applying this identity. In the previous session, we have seen some examples and how this identity is applied. In this session, we will look at some common mistakes which occur while applying this identity. Let's look at the first mistake. Can you tell whether this equation is an identity or not? The easiest way to find it out is to try putting a number instead of x and y. For example, let us take x as 2 and y as 4. By doing this, LHS will be 6 multiplied by 11, which is equal to 66, while the RHS will be 19 multiplied by 5, which is equal to 95. We can see that the value of left-hand side is not equal to right-hand side. This means this equation is not true for x is equal to 2 and y is equal to 4. Therefore, this equation is not an identity. We know that an equation which is true for every value of the variable in it is called an identity. Let's move on to the next common mistake. What is the value of 107 square? In the previous session, we have learned how to find the square of such numbers. First, we'll write 107 as 100 plus 7. Then we will find the square of it. Many of us make mistakes while expanding it. We write 100 plus 7 square as 100 square plus 7 square. But this is incorrect. Remember that it is an identity. A plus b square is equal to a square plus 2ab plus b square. Therefore, by applying identity, we will expand 100 plus 7 square in this way. After simplification, we will get this as our final answer. So, we should always keep in mind that a plus b square is not equal to a square plus b square. Let's check out one more example. What is the value of x square plus y square the whole square? Which option is right? Most of us think that the option A is correct. But this is an incorrect answer. While solving this, we think that x and y are already squared. So according to this identity, we write the answer as x square plus 2x square y square plus y square. But notice that here a should be x square but not x. Similarly, b should be y square but not y. As you can see here, we have not found the square of the first and second terms. So, the right-hand side of this expression will actually be x square whole square plus 2x square y square plus y square whole square. Therefore, the correct answer will be x raised to 4 plus 2x square y square plus y raised to 4. In this session, we have seen some common mistakes which occur while applying this identity. Friends, in the previous video, we saw what is an identity and we also saw this identity. In this video, we will see a new identity. Take a look at this equation. This is actually an identity. That means the expression on the left-hand side is equal to the expression on the right-hand side for any value of the variables a and b. But how did we get this identity? Can you find out? We know what is a raised to the power of 2. It is a multiplied by a. Similarly, a minus b raised to the power of 2 will be equal to a minus b multiplied by a minus b. Removing the brackets on the right-hand side, we will get a raised to the power of 2 minus ab minus ba plus b raised to the power of 2. Observe the two terms in the middle. Since ab is equal to ba, therefore, they can be combined to get this equation. So this is how we got this identity. To understand this identity better, let's look at this question. Suppose we have a square whose side is a. Let's divide this square into one smaller square and two rectangles. Suppose these two lengths are equal and we will denote it by b. Now, can you tell what will be the area of the smaller square? We know this length is a and this length is b. So the side of the smaller square will be a minus b. Therefore, the area of the smaller square will be equal to a minus b raised to the power of 2. But now, observe the area of the smaller square. It will be equal to the area of this square minus the area of this rectangle minus the area of this rectangle. We know that the area of this larger square is a raised to the power of 2. Now, the area of this rectangle will be equal to b multiplied by a minus b, and area of this rectangle will be equal to a multiplied by b. Now, let's first remove this bracket. Then the right-hand side becomes a raised to the power of 2 minus ba plus b raised to the power of 2 minus ab. Now, look at these terms again. They are equal to each other. So, solving this further, minus ab and minus ba become minus 2ab. Hence, we get a minus b raised to the power of 2 equal to a raised to the power of 2 minus 2ab plus b raised to the power of 2. We have seen an interesting way to get this identity. In this session, we saw this identity. In the next session, we will see some examples and understand how to use this identity. In the previous session, we had seen this identity. a minus b raised to the power of 2 is equal to a raised to the power of 2 minus 2ab plus b raised to the power of 2. In this session, we will see how to use this identity with the help of some examples. Let us see the first example. Let's say you have to find the square of a large number like 199. Multiplying 199 with 199 is time-consuming. Let's see how this identity will make it easier. First, let us try to represent this number with the help of two simple numbers. Can you tell what those two numbers would be? They would be 200 and 1. So, 199 can be written as 200 minus 1. Now, 199 raised to the power of 2 will be equal to 200 minus 1 raised to the power of 2. Now we can use this identity to expand 200 minus 1 raised to 2. Let's consider a equal to 200 and b equal to 1. Now substituting this on the right-hand side, we get 200 raised to the power of 2 minus 2 multiplied by 200 multiplied by 1 plus 1 raised to the power of 2. Now we can see that calculating these three terms is very easy. After further simplification, we will get this. Therefore, we see that to find the square of such numbers, we can use this identity. Let's see the next example. Can you find the value of 6.9 raised to the power of 2? It can be done in a similar way by splitting 6.9 into two simple numbers. Can you tell the two numbers which it can be split into? So, 6.9 can be split into two simple numbers, 7 and 0.1. So, 6.9 raised to the power of 2 will be equal to 7 minus 0.1 raised to the power of 2. 7 minus 0.1 raised to the power of 2 can be expanded with the help of this identity. Let's consider a as 7 and b as 0.1 here. Then, we will get this. After further simplification, we get this answer. Now let's look at one more example. Can you find the value of 8m minus 6n raised to the power of 2? We can find the value of this by using the same identity. Here, a will be equal to 8m and b will be equal to 6n. So, by substituting this in the identity, we will get this. Therefore, the final answer will be this. Now, let's look at one more example. Can you find the value of 3 by m minus 7 by n raised to the power of 2? We know that we will have to use the same identity here. Can you tell what value should be taken for a and b? Here we will consider a as 3 by m and b as 7 by n. Substituting these values in the identity, we will get this. Simplifying it further, we will get this as our final answer. In this session, we saw how to use this identity with the help of some examples. In the next session, we will see some common mistakes that we tend to make while using this identity. Friends, in the previous session, we saw some examples where we use this identity. In this session, we will look at some common mistakes that can happen while using this identity. Let me start by asking you this question. Can you find the value of 3x minus 2y raised to the power of 2? Which of the following options is correct? The correct option is D. Some of you might have got option A B or C as the answer. But all these are wrong options. Let us see why. We have the misconception that a minus b raised to the power of 2 will be equal to a raised to the power of 2 minus b raised to the power of 2. That is why we get option A as the answer. But this is not the correct answer. We have seen that a minus b raised to the power of 2 is equal to this and not this. So option A is incorrect. Now while expanding this, some of us apply this identity. But we write the minus sign over here like this. We tend to make this mistake because we see that the minus sign is associated with 2y. And so, while expanding, we write the square of 2y and we write the minus sign as it is, which is incorrect. So, option B is wrong. Some of us get option C as the answer because while using the identity, we tend to forget to multiply by 2. So, we end up getting the incorrect answer. Thus, option C is also wrong. Since we have to solve 3x minus 2y raised to the power of 2, here A will be 3x and B will be 2y. On solving this using this identity, we will get this. Hence, option D is the correct answer. Now look at this question. Can you tell which of the following is the correct option? The correct option is B. Some of you might have got A as the answer. But this is incorrect. Let us see why. We get option A as the answer because while finding the square of these two terms, we find the squares of x and y only. But we forget to square the coefficients associated with x and y. So we should ensure that along with variables, the square of their coefficients is also calculated. This question can be solved by using the same identity. Here, A is 4x and B is 5y. Therefore, the answer is this. Hence, the correct option is B. In this session, we saw some common mistakes that can happen while using this identity. In the previous session, we have seen this identity and its application. Now friends, in this session, we will see one more identity. Let us see this identity. This equation says that if we add two variables a and b and multiply it with a minus b, then it is equal to a square minus b square. Can you check if this is an identity? Let's see. Consider this expression. Let us simplify this by removing the brackets. It will be equal to this. Now, here since AB is same as BA, positive AB and negative AB will get cancelled. Therefore, we will get this. We can see that this is the expression on the right-hand side. Therefore, this is an identity. There is also an interesting way to prove this identity. Let's say we have a square and the length of its side is A. And we will remove a small square with side B from it. Can you tell me what will be the area of this remaining portion? There are two ways to find the area of this remaining portion. Let's look at the first one. We can see that this remaining area can be divided into two rectangles. The length of the first rectangle is equal to A and its breadth will be equal to A minus B. Now, let us consider the second rectangle. We can see that the breadth of this rectangle is b, and its length is equal to a minus b. But if we observe, the breadth of this rectangle is equal to the length of this rectangle, we can move this rectangle from here and fit it over here. By doing this, we get one big rectangle. The length of this big rectangle is a plus b and its breadth is a minus b. We know that the area of a rectangle is equal to its length times its breadth. Therefore, the area of this rectangle will be a plus b multiplied by a minus b. So, we get the area of this remaining portion to be this. There is another way to find this area. This area is actually equal to the area of this larger square minus the area of this smaller square. What will be the area of these two squares? The area of larger square will be a square and the area of the smaller square will be b square. Therefore, the area of this remaining portion will be equal to a square minus b square. Since these two expressions are equal to the area of this remaining portion, these two expressions will be equal to each other. This way, we prove this identity. So in this session, we have seen this identity. In the next session, we will see some examples related to the usage of this identity. In the previous session, we have seen this identity. Friends, in this session, we will see some examples based on this identity. Look at this question. Can you find the solution of this? When you observe these two expressions, you can see that this is in the form of a plus b, a minus b. Here, a is 2x and b is 3y. Now, you can simplify this by using this identity. The result will be equal to 2x square minus 3y square. And the final answer will be this. Therefore, we can say that by using this identity, we can directly find the product of similar expressions. Let us move on to the next example. Can you find the value of this? Can we use this identity here? We can see that this is in the form of a square minus b square. Here, a is 5.04 and b is 4.96. So this means this expression will be equal to this. On further simplification, we will get this. So, this is another way of applying this identity. Let us look at the next example. Can you find the answer to this? We can see that this expression is in this form. Here, a is 3 by m and b is 2 by n. We know that similar questions can be solved using this identity. So, by substituting the values of a and b, we get this. Simplifying it further, we get this as the final answer. This way, we can even solve similar expressions using this identity. Let us now look at the last example related to this identity. Can you find the answer for this expression? We can solve this expression in two parts. This is the first part and this is the second part. Consider the first part. Since it is in the form of this identity, we can write it like this. Now, consider the second part. We can solve it in the same way. So we'll get this. Now, let's substitute these expressions we got in this expression. We can see that minus m square and plus m square will cancel each other. So, we will get this as the final answer. In this session, we have seen some examples based on this identity. In the next session, we will see some common mistakes that can occur while using this identity. Friends, in the previous session, we have seen the usage of this identity. In this session, we will see some common mistakes that can occur while using this identity. Look at the first question. Can you tell me the correct option? The correct option is B. Some of you might have got option A as the answer. Let us see why. We know that we have to use this identity in order to find the answer. But what should we take in the place of A and B? This is where we make a mistake. We take A as X and B as Y. So, we get this. Now we just multiply these coefficients like this. So we get option A as the answer. But this is an incorrect answer. We should take A as 3x and B as 2y. Solving this identity, we get this as answer. Therefore, the correct option is B. So we should be careful to ensure that the square of the coefficients are also kept in mind along with the variables. Look at the next question. Can you solve this expression? For solving such type of expressions, we have studied these identities. Which of these identities can be used to solve this? Currently, it looks like this expression doesn't fit into any of these identities. But does this mean we cannot solve this using an identity? No, it's not like this. We can solve this using this identity. Let us see how. We can simply rearrange the second bracket like this. Now, if we look at this, we can say that our expression is in the form of this. In A plus B, A minus B, A is 2C and B is 3D. Now using this identity, we can solve this expression. Hence, the answer can be given as these two terms. So, in the given expression, we should always check if the terms can be rearranged so that it can be written in the form of standard identity. In this session, we have seen some common mistakes that can occur while using this identity. Friends, in this session we will see a new identity. Can you find out if this is actually an identity? Consider the left-hand side of this identity. To simplify this, we need to remove the brackets. After multiplication, we will get this expression. But this doesn't look like the right-hand side of our identity. So how do we get that? when we look at these two middle terms, we can see that they both have variable x in common. We can take that x as common and write it like this. And now, we can see that this is the same as the right-hand side of this identity. Therefore, this given expression is an identity. Now, let us look at another way to prove this identity. For that, let us consider this rectangle and divide it in 4 parts as shown in the figure. Now suppose we have to find the area of this rectangle. How can we do that? There are 2 ways to find the area of this rectangle. Let us see the first one. We know that the area of a rectangle is equal to the product of its length and breadth. Can you tell me which is the length and which is the breadth? The length of this square is x and the length of this part is a. Therefore, the total breadth of this rectangle is x plus a. The length of this square is x and the length of this part is b. Therefore, the total length of this rectangle is x plus b. So this is the length and this is the breadth. Substituting these values in this, we get this. Now, let us see the second way to find the area of this rectangle. As you can see that this rectangle is made up of 4 parts. So the area of this rectangle is equal to the sum of the areas of these 4 parts. Area of the first part is equal to x times x, which is equal to x square. Similarly, area of the second part will be a times x, area of the third part will be b times x, and area of the fourth part will be a times b. Taking x as common from the middle 2 terms, we will get the final answer as this. The area of the rectangle that we get using both the methods will be equal. As you can see, that this is the same identity that we saw earlier. In this session, we have seen this identity. In the next session, we will see some examples based on this identity. In the previous session, we have seen this identity. Friends, in this session, we will see some examples based on this identity. Can you tell me how to solve this? This can be easily solved using this identity. Let's compare these expressions with the left-hand side of this identity. We can see that x is 2x, a is 3, and b is 5. Substituting these values in this identity, we will get this. After further simplification, we will get this as our final answer. This was easy, right? Let us see if you can solve the next example or not. Can you tell me what will be the product of this? Again, we can apply this identity. Here x can be taken as LMN, a is minus 3 and b is minus 2. Let's substitute them in the identity. After further simplification, we get this as our final answer. Can you find the answer to this last example? In this example, how can we use this identity? In order to do this, we have to split these two numbers like this. You can notice that Even after splitting both the numbers, the product remains equal. Now, we can solve the right-hand side using this identity. Here, x is 200, a is 4 and b is 5. Substituting these values in the identity, we will get this. On further simplification, we get this as the final answer. In this session, we have seen some examples based on this identity. In the next session, we will see some common mistakes that can occur while using this identity. In the previous session, we have seen some examples based on application of this identity. Friends, in this session, we will see a common mistake that can happen while using this identity. Look at this question. Let me give you two options. Which is the correct option? The correct option is B. Some of us might have got option A as the answer, but this is incorrect. Let us see why we get option A as the answer. Focus on the given question. We have seen how to solve such examples using this identity. First, we will split the given numbers into simple numbers like this. Now this appears to be in this form. We can find the value of this by using this identity. But we tend to make mistakes while applying this identity. Substituting the values in this identity, some of us get this. After further simplification, we end up getting this as the answer. But this is not correct. Look at this step. According to the identity, at both these places we have substituted the value of a as 3. But if we carefully observe this, we could see that the value of a is not 3, but it is -3. Therefore, we get an incorrect answer. The correct step would be this. After further simplification, we will get this. Therefore, option B is the correct answer. So we should be very careful while identifying the values of A and B. Even if there is a plus sign associated with A and B in our identity, that doesn't mean that A and B will always be positive. A and B can also be negative. So in this session, we have seen a common mistake that can happen while using this identity.